Most state-of-the-art electronic devices have lithium-ion batteries. Despite their good performance, they have one significant drawback: a high fire hazard. In 2016, the International Civil Aviation Organization banned the transportation of lithium-ion batteries in passenger luggage. This dangerous cargo can catch fire and cause a plane to crash. One of the largest smartphone manufacturers recalled all new model phones due to exploding batteries the same year. How can we prevent the spread of fire and protect people and their equipment in such cases? Russian scientists have developed an autonomous means of putting out fires at an early stage. It will help protect our phones and laptops, electric vehicles, household devices such as sockets and extension cords, and much more.
A fire in lithium-ion battery-based devices spreads very quickly. Instantly, the fire spreads faster than a person can react. A person won't have time to put it out. By the time they've pulled the pin out of the fire extinguisher, everything is burned. We have to kill the fire at its very source. This is what our development is about. It's a fire extinguishing agent. As strange as it may sound, it does all the work. It discovers the source of the fire, it responds, and puts out the fire.
I studied at Dmitry Mendeleev University of Chemical Technology of Russia, at the Department of Nanomaterials. I have been studying fire safety and materials that ensure fire safety since I was a student. This solution is quite unique, and it differs from all the available fire extinguishing equipment. I looked at people's reactions, and every time I saw excitement in their eyes when they watched a simple plate put out a fire. All kinds of fires. Whether it's a lighter, whether it's combustion, whether it's a gas burner or a gasoline flame.
It's not just some rubber. It's a composite material. Over 50% of it is microcapsules, plastic cells containing a liquid, which acts as a fire extinguishing agent. These are microcapsules. What is a microcapsule? It's a core shell structure, like fish eggs. It's a material that contains, about 100,000 microcapsules, 100,000 small fire extinguishers, which will release their contents and put out the fire.
Luba, can you explain how the fire extinguishing material works?
Once exposed to a fire or at a temperature above 120 degrees Celsius, overpressure is created inside the microcapsule. The pressure destroys its shell. As a result, there is a pulsed release of a substance that puts out the flame.
This can be used in any electrical product, from a basic socket in the office to the most capacious lithium-ion battery in satellites in space or on a submarine. Our materials are meant for lithium-ion batteries, but it's a particular type of electrical equipment. In general, you can protect a variety of things, some hard to reach or small objects. This is an extension cord. It's the second most common cause of household fires in the United States. Look here. There are small pieces of our material. Their quantity is 10 times more than enough. If there is a first, second, third short circuit, then a fire happens. This material will put out the fire. It won't help prevent short circuits. But there will be no fire, no flame spreading throughout the room or apartment. If we are talking about objects prone to a specific fire control, lithium batteries have a high energy density, then we will need a larger volume of material. Accordingly, this piece, which I have in my hands, is about 150 grams, and it will be able to protect 30 liters of capacity. If we are talking about equipment, for example, a scooter, popular electric scooters, then this kind of piece will be enough for its battery. This is a pouch cell battery, the most combustible one. Here we show how we protect a pouch battery with our product. We suggest laying a small plate of our material in between the cells.
This material requires no additional mechanisms and no human involvement. The fire suppression time is 10 seconds. At that speed, the fire does not have time to spread, and the equipment is not disabled.
The very idea of encapsulating and creating materials based on encapsulated extinguishing agents, refrigerants, which is what this material is, has been known for a long time. This idea appeared back in Soviet times. In the 80s, it was called an active flame retardant. The names changed over time, but the essence of the agent has remained the same. That is, it has a core shell, a polymer microcapsule, a fire extinguishing agent inside, and all these make up a product.
There are many fire extinguishing agents, over 100, but of these 100, 96 are banned for use. Why are they banned? As a rule, they cause the greenhouse effect or destroy the ozone layer. Therefore, international laws, the Montreal and Kyoto protocols prohibit their use and production, and such fire extinguishing agents are quite expensive and harmful to both the atmosphere and people. But the world is evolving, technology is developing, and some Chinese manufacturers, like the Russian ones, have offered safe fire extinguishing agents like perfluoroketone. It is used in our developments.
What was the problem? Previous technologies have become out of date, obsolete, since perfluoroketone cannot be encapsulated with methods that were used earlier. We have developed a technology from scratch that allows us to enclose this green fire extinguishing agent in a core shell structure, store it for a long time, and process it into some products that will have fire extinguishing properties.
In order to create this shell, synthesize it, and obtain these microcapsules, we performed about 300 tests. I am a very skeptical person. I didn't believe it would succeed at first. Usually, you mix the core, mix the shell material, and you get nothing. It looks messy like some kind of porridge, and then you take a microscope and see a capsule. It means that the technology works. When we saw it, my team members who had been working on it for so long were overjoyed that the test turned out to be a success.
This is the fire extinguishing agent we use. As you can see, it is a liquid. We are converting this liquid into this form. This is the most difficult, the most painstaking thing. This is our know-how. You can see a polymer shell cooking in a red liquid behind me. This is the shell material to enclose the liquid in, so the red mixture will later become this polymer on the surface of this liquid. We mix these microcapsules with a polymer binder, add some technological additives, and get some kind of sheet product, which will already have the same properties as capsules that work with this substance.
Now, our company has 3 patents. The first one is for our technique for microcapsulating a fire extinguishing agent, and the other patents are for the fire extinguishing materials. This method keeps the perfluoroketone inside microcapsules unchanged for 10 years. This is the main difference between us and our analogs and competitors. We also don't use any substances from the first or second hazard class in our technology. No toxic substances. This is our main advantage, and we always emphasize this. Our technology meets all green chemistry requirements. Why did I choose the field of fire safety as my scientific, applied, and commercial interest? Because I want to protect people, protect lives, save lives. I know it sounds pretentious, but such a plate can save a life. For example, if we are talking about protecting public transport with such materials, then people will be able to evacuate before a fire starts, or there will be no fire at all. Some cell goes out of order, the material works, the electric bus keeps going, it reaches its destination, then servicemen run some tests and see that something was wrong with it. This will save lives and reduce the workload of fire brigades.
Luba, can you show me how microcapsules burst and put out a fire?
Give me a moment.